All right, this is for Chemistry CP, debrief on the worksheet called Molecular Mass Worksheet. Determine the molecular mass in units of grams per mole for the following substances, beginning with copper 2 hydroxide. So the process is you have to use the periodic table quite a bit and look up the molar mass of copper. On my periodic table, it says 63.546. That's atomic mass unit for grams per mole. I suppose I could jot this out a little bit. So for copper, it is 63.546. For the hydroxides, I have two of them. Two hydroxides, which means I have two oxygens. So for the oxygen, it's 2 times, and my periodic table lists it at 15.999. Yours might just say 16.00. For the hydrogens, two of those, so 2 times 1.008. Add all of that together. So here we go. 63.546 plus 2 times 15.999 plus 1.008, close parentheses, enter. And the result is, and I see I have a mistake here. Whoa, that is way unreasonably large because I put a multiplication symbol where I should have put a plus sign. So let me recall this instruction and replace that multiplication symbol with a plus sign, enter, and I get a much more reasonable, believable value, 97.56. So 97 point, I'll round it off and call it 6 grams per mole. That is the molecular mass of copper 2 hydroxide. Number 2, kind of interesting that there's no number 3. Oh, I see, there's 3. So number 2, and we just do this over and over again. So for the sodiums, I have 3 times each sodium, which is 22.990. I have 1 phosphorus, which is 30.974. I have 4 oxygens, which is 15.999. I use my calculator. 3 times 22.99 plus 30.974 plus 4 times 15.999. And it reports 164 grams per mole. 164 grams per mole of this. Number 3, chlorine, which is a diatomic molecule, one of the 7. So I have 2 chlorines here, and on my periodic table, each chlorine is 35.45 atomic mass units. I wrote a 7, but that's supposed to be a 4. So 2 times 35.45, enter, and my calculator says 70.9 grams per mole. Number 4, I have 1 silver, 1 manganese, and 4 oxygens. So into my calculator, yeah, sure. I guess I'll write them out. So for the silver, I have 107.87. For the manganese, I have 54.938. For the oxygens, I have 4 times 15.999. So 107.87 plus 54.938 plus 4 times 15.999. Enter, and I get 227 grams per mole. Number 5, it has a name. NO3 is called nitrate. So this would be hydrogen nitrate. Well, it's going to be one hydrogen, which is 1.008, one nitrogen, which is 14.007, and three oxygens, which is 15.999, 1.008 plus 14.007 plus 3 times 15.999, and I get 63.0 grams per mole. Number 4, potassium sulfate. I have 2 potassiums. Potassium is 39.098. I have 1 sulfur, which is 32.06, and I have 4 oxygen, which is 15.999. So 39.098 plus 32.06 plus 4 times 15.999, enter. And again, we can see that's an unreasonable answer because I have a multiplication symbol where I should not have a multiplication symbol. So I'm going to re-enter this variable with a plus sign, replacing that multiplication sign. And now I have a much more reasonable result, 135 grams per mole. Number 7, iron 3 bromide. So now you're not being given the chemical formula, you're given the chemical name. And the 3 means it's an oxidation plus 3 state. Bromine, being a halogen, is always a 1 minus state. So I'm going to need 3 bromines to neutralize the charge on this iron 3 ion. So now that I've written it correctly, I go to the periodic table and I say, okay, so iron is 55.845, and I need 3 bromines. Each one is 79.904 or 04. So 55.845 plus 3 times 79.904, enter. And it says 296 grams per mole. I'm just going to do everything to only 3 sig figs. Dinitrogen pentoxide, or pentaoxide. So nitrogen is N, di means 2, oxide is oxygen, penta means 5. So dinitrogen pentaoxide means I have 2 times 14.007 for the nitrogen, and 5 times, you guessed it, 15.999 for the oxygen. So 2 times 14.007 plus 5 times 15.999, enter, and I get 108. 108, I suppose, grams per mole is the molar mass of dinitrogen pentoxide. Magnesium nitride. Well, magnesium is always a 2 plus charge, and nitride means just nitrogen, not nitrate, not nitrite, just nitrogen. Nitrogen is always a 3 minus charge. So I'm going to have to do a crisscross and do 3 magnesiums for every 2 nitrogens to make this electrically neutral. So that's going to work out to be 3 times 24.305 plus 2 times 14.007. 3 times 24.305 plus 2 times 14.007. Enter. And clearly I made a mistake. Somehow I hit the log button. Who knows? Let's just clear and do it correctly this time. 3 times 24.305 plus 2 times 14.007. Enter. Now I have a reasonable result, 101 grams per mole. Don't truncate, but round correctly. Mercury 2 cyanide. Mercury is Hg. The Roman numeral 2 means it's going to be a 2 plus charge. Cyanide is a polyatomic ion that means Cn with a 1 minus charge. And so I'm going to need 2 cyanides for every mercury 2 plus. So open parentheses, Cn, close parentheses, subscript 2, and this is mercury 2 cyanide. Mercury is 200.59 atomic mass units. I have 2 carbons and 2 nitrogens. So I could do them individually and say 2 times 12.011 and 2 times 14.007, 200.59 plus 2, and I'm going to open parentheses and go 12.011 plus 14.007, close parentheses. And that looks like a reasonable result, 253 grams per mole. Number 11, convert the following to grams. 0.575 moles of sodium chloride. Well, first I need to know how many grams there are in 1 mole of this substance. That's what we've just been doing for 1 through 10. So first step is to go to the periodic table and look up the molar mass of sodium, which is 22.990. Add to that the molar mass of chlorine, which is 35.45. 22.990 plus 35.45 is 58.4. And I'll even carry out one more digit, 44 grams per mole. So now this conversion table would start off 0.575 moles times 58.44 grams per mole. The moles will cancel. And I have my 58.44 times 0.575. Yep, 0.575. Enter, and there's the result. 0.575 moles of sodium chloride results in 33.6 grams. 33.6 grams of NaCl, sodium chloride. Number 12. 3.80 times 10 to the 22nd power molecules of iron 3 hydroxide. It is still necessary to calculate the molar mass. Even though we're dealing with molecules here, we're going to turn these molecules into moles, turn the molecules into grams. So iron is 55.845 atomic mass units. I have 3 oxygens. So for the oxygen, it's 3 times 15.999. I have 3 hydrogens. So for the hydrogen, it's 3 times 1.008. 55.845 plus 3 times, open parentheses, 15.999 plus 1.008, close parentheses, enter. And it says I get 106.9. I'll do it 4 digits, right? 106.9 grams per mole. So if I start with 3.80 times 10 to the 22nd power molecules, that's not moles. I don't want to abbreviate it, MOL. That would be wrong. Molecules. I first have to convert that to the number of moles it is by saying that 1 mole is equal to Avogadro's number, which is 6.022 times 10 to the 23rd power, which we write symbolically as Na, Avogadro's number. Then I can multiply the number of moles by the molar mass of 106.9 grams per mole. So the moles will cancel, the number of molecules will cancel. I go 3.80 times 10 to the 22nd power divided by 6.022 times 10 to the 23rd power times 106.9 grams per mole. Enter. And what I have isn't much, 6.75 grams. 6.75 grams of iron 3 hydroxide. Number 13. I have 1.80 times 10 to the 21st molecules of water, H2O. Well, water is 2 hydrogens, 2 times 1.008, and then for the oxygens, it's 15.999. When I add them together, 2 times 1.008 plus 15.999, enter, I get 18.0. It says 1.5. I guess to 4 sig figs, I'll just round it up to 2 grams per mole. Now, I need to go from molecules to moles and moles to grams. So 1.80 times 10 to the 21st power molecules times 1 mole per Avogadro's number times 18.02 grams per mole. So here we go, 1.80 times 10 to the 21st power divided by 6.022 times 10 to the 23rd power times 18.02 grams per mole. And I don't get much water out of here. M mass equals 0.053, because these are placeholders, they don't count for sig figs. So right now I have 2 sig figs written down, 5, 3, and I'll make the next digit 9. It rounds up, 8, 6 rounds up to 9 grams of water. Number 14, I have 1.85 moles of carbon dioxide. Well, carbon is, from the periodic table, 12.011 AMUs. Oxygen, I think you know by now, is, I have 2 of them, and each one is 15.999. So the molecular mass of carbon dioxide is 12.011 plus 2 times 15.999. Enter. And I get 44.01. 44.01 grams per mole. Here, I don't start with molecules, I'm already in moles. So 1.85 moles of CO2 times 44.01 grams per mole of CO2. So I multiply this result by 1.85, enter, and I didn't bother rounding, re-entering the numbers, so I get 81.4 to 3 6 81.4 grams of CO2 is the mass in this situation. Number 15, 6.02 times 10 to the 24th molecules of zinc sulfate. I still need to work out the molar mass for each one of these. So for zinc, periodic table says it's 65.38 atomic mass units. For the sulfur, I only have one of those, and it's 32.06 atomic mass units. For the oxygen, I have four of those, and by now you've got it memorized. It's 15.999 or 16.00 on your periodic table. So 65.38 plus 32.06 plus 4 times 15.999, enter, and I get 161.4 grams per mole. 161.4 grams per mole. Next, I take the number of molecules, turn them into the number of moles, take the number of moles, multiply the grams per mole, and I'll have the answer. So that's going to be 6.02 times 10 to the 24th power molecules times 1 mole per Avogadro's number, which is 6.022 times 10 to the 23rd power. So in your head, you would say this is 10 moles times 161.4 grams per mole. So without a calculator, I would say the resultant mass is 1,610 grams of zinc sulfate. That would be 10 moles of it. If you really care about that fourth digit, then you would have to go 6.02. And, I could just type this in as 60.2 divided by 6.022. But if you're not that good on your math skills, we'll do it the long way. 6.02 times 10 to the 24th divided by 6.022 times 10 to the 23rd times 161.4, enter, and we get 1,610 grams. Okay, number 16. I have 4.15 moles of sugar. C6H12O6, I believe, is sugar, not too sure. So for the carbon, I have 6 times 12.011 atomic mass units. For the hydrogen, I have 12 times 1.008. For the oxygen, I have 6 times, do you know the number? 15.999 or 16.00. So 6 times 12.011 plus 12 times 1.008 plus 6 times 15.999. Aren't calculators useful? And I get 180.2. 180.2 grams per mole. So if I have 4.15 moles of that, 4.15 moles times 180.2 grams per mole means the mass of the sugar is 748 grams. 748 grams. Number 17. Use the following balanced reaction and convert the coefficients of moles into grams. All right. So it says here, for every 2 molecules of aluminum phosphate that I combine with 3 atoms of iron, I create 1 molecule of iron, probably 2 phosphate, plus 2 aluminum atoms. And just as a check, does phosphate have a 3- charge? I go to my list of polyatomic ions and I look up phosphate, and sure enough, PO4 has a 3- charge, which explains why there's a subscript 2 here and a subscript 3 there. So they had to crisscross. So this is iron Roman numeral 2 phosphate. Not that we care. What we're going to do is we have to calculate the molar mass of each one of these components, 2 reactants, 2 products. Yikes. Oh, so here we go. First, I'm going to treat this as if it were 1 aluminum. And I could get daring and just put all this into my calculator without showing much work. That would be daring. Oh, something's going on. Let's pause. All right, so for aluminum, it says it's 26.982 atomic mass units. For phosphorus, it's 30.974. And for the oxygens, go ahead, guess. It's 4 times 15.999. So that total is 26.982 plus 30.974 plus 4 times 15.999. And I get 121.95, which is 122.0. Now, I'm going to go ahead and already double it because of this coefficient. So I'll call it 122.0, but then I'm going to multiply it by 2 already because that's what will be next. And so I really am dealing with 244 grams of this first substance, aluminum phosphate, 244 grams of that. For the iron, 1 iron atom is 55.845. But I'm going to have 3 of those. So 55.845 times 3 is 168 grams. So I have 168 grams of iron. The total on the right has to equal the total on the left. So if I go 244 plus 168, I get 412 grams on the left. My total on the right should add up to 412 grams within round off error. To produce that, I guess I could just take the mass of 2 aluminums and subtract it from that total, and that'll save me the work of doing all this. But where's the fun in that? So for this iron 2 phosphate, I have, for the iron, I have 3 times the atomic mass of iron, which is 55.845. I have 2 phosphates. So how about if I do 2 times open parentheses, and then for the phosphate, I do 30.974, and then for the oxygens, I do 4 times, go ahead, have you memorized it? 15.999, close parentheses. And I'm only going to have 1 mole of this. So this will work out 3 times 55.845 plus 2, open parentheses, 30.974 plus 4 times 15.999, close parentheses, and that should work adequately. It's scrolled so you can't see it, but believing, oh no, that is the whole thing. So 3 irons plus 2 phosphates is 357.5. I'll call it 350, yeah, 357 grams per mole, or 357 grams in this case. And that's for 1 mole of it. So by subtraction, we should know what the aluminum will be, but just to do it properly, for aluminum, its mass is 26.982 atomic mass units. So if I go 2 times 26.982, enter, I get 53.96, which rounds up to 54.0, 54.0 grams of aluminum. Now, I remind you that on the left, I had 244 plus 168 added up to 412 grams. On the right, 357 plus 54 add up to 411 grams. Try not to freak out. Within rounding off to 3 sig figs, they agree with each other. If I were to carry out all of my calculations to 4 sig figs, then there would be closer agreement. Okay, this ends this debriefing.